Chainlink is a decentralized Oracle network that connects smart contracts with real-world data. The white paper, released in 2017 by Sergey Nazarov and Steve Ellis, outlines how blockchains can securely interact with external information, payment systems, and APIs. While blockchains are powerful for verifiable agreements, they cannot access data outside their networks. Chainlink solves this limitation by introducing oracles, trusted data feeds that bridge smart contracts and the outside world. At its core, Chainlink is an infrastructure for decentralized trust. Smart contracts can only execute logic based on on-chain data, but many use cases depend on external information such as market prices, weather conditions, or random numbers. A blockchain without an oracle is isolated. By providing a secure channel for verified data, Chainlink turns static agreements into dynamic, real-world applications. The Chainlink whitepaper describes three main components: on-chain contracts, off-chain oracles, and a reputation system. On-chain contracts handle user requests for data through a service-level agreement, which defines the data type, number of oracles, and acceptance conditions. When a request is made, Chainlink automatically matches it with qualified oracle nodes. Off-chain oracles are independent nodes that gather and deliver information from APIs, databases, or financial systems. When a data request is broadcast, multiple oracles collect results from different sources. Their responses are aggregated on-chain to produce a single reliable output. This process removes single points of failure and ensures integrity through redundancy and verification. The reputation system tracks oracle performance, accuracy, response time, and reliability. Nodes with strong records gain higher chances of selection, while poor performers lose credibility and rewards. Economic incentives align honest reporting with profit, creating a competitive market for accurate data. In essence, Chainlink decentralizes trust at the data input layer in the same way blockchains decentralized record keeping. The Link token powers the system. Users pay oracle nodes in Link for delivering data and services. Accurate oracles earn Link, while those that fail lose revenue or reputation. Tokens can also serve as collateral, deterring malicious activity. The result is a self-regulating network where market forces encourage reliability. Several smart contracts support this process. The reputation contract evaluates node history, the order matching contract pairs users with nodes by price and performance, and the aggregation contract compiles individual results into one verifiable dataset. Together, these layers create a modular, scalable oracle network. A major innovation lies in Chainlink's off-chain architecture. Each node can connect to multiple APIs and legacy systems, linking blockchains with traditional data providers and banks. Nodes can run external adapters to interact with payment networks such as SWIFT or Visa. This design makes Chainlink a universal middleware between decentralized and conventional finance, enabling hybrid smart contracts that respond to real-world events. The white paper emphasizes the importance of verifiable randomness and tamper-proof data for decentralized finance, insurance, and gaming. Later upgrades extended these principles through Chainlink VRF, verifiable random function, and proof of reserve feeds that audit real-world assets like stable coins or commodities. These features strengthen the integrity of data entering blockchains. By decentralizing data input and output, Chainlink enhances the security of smart contracts without sacrificing transparency. Developers can automate agreements triggered by real-world conditions, DeFi protocols calculating interest rates, insurance contracts reacting to weather, or games relying on provably fair randomness. In each case, Chainlink acts as the connective layer that makes automation trustworthy. In broader context, the Chainlink whitepaper marked a turning point for blockchain utility. It introduced a practical way for smart contracts to interact with external systems safely. Without oracles, blockchains remain isolated. With Chainlink, they become programmable environments that mirror real-world complexity. Today, Chainlink secures billions in on-chain value and supports thousands of decentralized applications. Its architecture still follows the original design principles: decentralization, transparency, and data integrity, while evolving through staking, cross-chain interoperability, and modular upgrades. By bridging blockchain logic with real-world events, Chainlink transforms smart contracts from theoretical tools into practical infrastructure. It remains one of the few projects whose white paper continues to guide the direction of decentralized finance and Web3 development. For more insights on Oracle networks, hybrid smart contracts, and data integrity in blockchain systems, remember to like, subscribe, and keep learning here at Crypto in Black and White.